Ok, stanno rientrando. Allora, ci prepariamo e ci avviamo verso la chiusura dei lavori di oggi con il professor Oppenheimer, Università di Cambridge, anche lui un rientro a Pompei dopo un po' di tempo, che farà anche da introduzione per l'ultimissima parte del pomeriggio, in cui verrà presentato il documentario che ha realizzato proprio il professore. Quindi do la parola al professor Clive Oppenheimer, Some Perspective on Documentary Filmmaking. Prego.
Grazie, Alessandro. And thank you all for coming along, staying late in the afternoon. And a huge thanks to the organization, to the director, to Valeria, Chiara, Eunice, for the invitation and the hospitality and for putting on a spectacular program. I mean, today I've had thankfully the smell of bread has covered the smell of the garum earlier, and we had some music. It's really been a spectacular learning experience for me, as well with the conversations we've had. So I have a little presentation for you related to my experiences in documentary filmmaking, and then we have a film to watch afterwards. So let me begin by just reflecting on some of the themes of the conference, and these are just a few of the little snippets of presentations from yesterday that caught my eye or my ear. Chiara, conservation requires interpretation between the language of research and the language of protection. This is something that's, of course, important in these very multidisciplinary contexts in which we work. We need a common language, or not a common language. We need to take time to understand each other's epistemologies and try and interpret between our different fields. I like this from Eunice. The conservation of heritage starts from a choice, even before an idea we choose where to dig. This also has a resonance for me, I think, and this is true more generally in film. Before we even start collecting, press start on the camera, we're making a choice. We're editing as soon as we have a camera in our hands, because we can press on or off. What happens in a natural disaster is not exactly what happens on a normal day, an understatement from Valeria. And I think this is something, again, that I find interesting in filmmaking, is juxtaposing the everyday, the normal, with things that are very strange. And the film I'm making at the moment, actually, I think does this. It's looking at fieldwork in Antarctica, and you see very domestic routines underway, but you also see people doing very extraordinary things with their scientific work. And the bones are heritage. There is so much that is hidden, that is latent, often that we have discarded. I thought too of the dust, the pollen spreading from that pine tree, and how, unless we're careful, we miss this. And I think also that when we can have facts, lots and lots of facts, but there's a truth behind those facts that actually goes much deeper than just the facts themselves. So my beginnings in filmmaking began 20 years ago when I collaborated with a German-Italian artist, Armin Linker, who was then based in Milano. And he had a commission to make a video installation on the theme of volcanoes. And he gave me a film camera to take on my field work to assorted volcanoes. This was a wonderful moment for me to... he told me that we would go to the Venice Biennale. You can imagine my excitement. We went to the Festival Internazionale per Eredobagno in Bologna. And if you're in in toilet furnishings, it's the #1 international conference, but we got to show our installation. And I had this film camera with me on fieldwork in Antarctica, and this is where I got to meet a much more famous filmmaker, Werner Herzog, who was making this movie, Encounters at the End of the World. So this is 20 years, nearly 20 years ago. Werner's film didn't screen at the Redobagno Festival in Bologna. It was an Oscar-nominated film, so it was had a much wider distribution. But this began my friendship with Werner Herzog, and that led to our collaboration in film. And the first film that we made is on the theme of volcanoes, and what this had begun with. I was writing a book on large eruptions of the past, and had imagined making a documentary on this topic. And in particular, most of the documentaries you can see on volcanoes have a very similar theme. There will be a volcanologist who's invented something, and it's going to predict the eruption, and it's going to save the poor people. And there will be somewhere in the film, it's not a question of if it's going to erupt, but when. And it will cut to a commercial break, and you'll have to wait for the resolution. And I always felt that was missing a lot of the stories that you will all be familiar with, that volcanoes are not just about the catastrophe. They're about the millennia between these big explosive events when people live on the volcanoes. It's not for nothing that the best mozzarella comes from this region, I'm sure. So Werner and I collaborated in making this film, and this was, for me, a very steep learning curve in storytelling, in crafting a narrative backbone to a film. And at the end of it, I was very much captivated by the filmmaking process, and I wanted to do more. And the next film I made came to me through a visit to South Korea and to the Polar Research Institute in South Korea. And I'll show you a little video that I took when it just came to me. With Werner, I've made a film about the underworld. Now it's time to make a film about heaven and the heavens. And this was the inspiration.
Our Antarctic meteorite collections, including iron meteorites, ordinary chondrites, and basaltic achondrites, and carbonaceous chondrites. So now we have 950 Antarctic meteorites, and here you can see iron meteorites, not all from Antarctica. So the second one is the iron meteorite found in Antarctica. This very, there's no crystal structures, but in the electron microscope you can see some typical structures with them. And here, the second one, that's lunar meteorites, very rare and very unique. And that meteorite was found in the mountain Duit in West Antarctica, not Eastern Antarctica, sorry.
So what struck me about this is the veneration of these objects. They're in an ultra clean lab, and on top of that, they're in these cubicles with nitrogen atmospheres to preserve. Some of these are organic meteorites, and it was partly this veneration of these stones and their spectacular beauty that made me think this is a topic for the next movie. And so I teamed up again with Werner. It took me a couple of weeks to write a pitch for this film, with which I was able then to approach funders. We got a very sizable charitable donation from the Simons Foundation. And from the initial concept to making the film, the release of the film, it was about a 3-year process. And the first 2 years were financing the film. So we had to piece together the finances. So the film started with a vision. It started with this idea, but it had to then involve a great deal of research. And I think that's something as researchers, academics, and in institutions, museums, we know what research is. We know how to go deep into a topic. We know how to read the literature, and we're even familiar with reading literature outside our own field sometimes because we're trying to push in a new direction. And for example, with the volcano film, this was some of the locations we filmed in were underpinned by research that I'd been involved with. And I just show you here an example. I have some geoarchaeological credentials through work on obsidian provenancing. So deep ramifying research underpins a good film, a good documentary movie. So you have your vision, you've done the research, you need to recruit your crew. What you're doing in making a film is you're having a child, and you have to do everything you can that this film will have a great life when it leaves you, when it goes out into the world. You can't do anything more about it. You've finished the film. Up until that point, you have to do everything you can for its future. So, of course, I had the good fortune to collaborate with Werner Herzog, who's made nearly 100 movies in his long career, but also to work with Peter Zeitlinger, a cinematographer who lives up in Friuli, who's also filmed about 30 of Werner's movies. The sound engineer is important. All of the people involved in making a film are important, are members of a team. And you have to do good casting for the film. You need to find protagonists that have, of course, the expertise, but also you want to do a little bit of background research to imagine how they might be on camera. Sometimes you can't do this. Sometimes you can't find somebody who has a video on YouTube. And then, in all cases, when you're filming with your protagonist, you have to do everything you can to elevate the performance. Again, you're doing all you can to make the film successful. This is a little example from the second film that Werner and I made called Fireball. And you'll see here an artist by the name of Katie Darkey in a community in northwestern Australia. And here she is depicted the meteorite impact crater, Kandi Malal. So I'll just show you a little clip here.
That's what we're looking at here. It's a beautiful painting.
This is the sandhill, and this is the grass. And it haven't got any gandhi, no potatoes. Long time ago, the old people said one man went hunting through the creeks, hunting for birds. But
she's explaining that the formation of the impact crater is the descent of the rainbow serpent into the ground, and she has a story here about the search for sweet potatoes going across the crater.
And in this story,
and finding Katie for this film involved doing some reconnaissance, meeting her beforehand, and when we actually turned up to film, she wasn't in the community. It turned out she'd gone 400 kilometers away with her son who needed the dentist. We needed her for the film. We waited for her at the bus station when she came back and took us straight to the art center to film with her. So the casting is very important. Sometimes it's serendipitous how things work out. One of the things I think about with film, of course, a film, it must have a very strong cinematic appeal. If it doesn't, then make a podcast. You don't need to use film if it doesn't have a strong visual element. And so that leads me to think very carefully not only of the casting of protagonists, but also casting, if you like, of the situation. And this is an example. This is just a screen grab from Fireball. Nita Sahai is a specialist at the interface between geochemistry and biology, and she's studying the origins of life and looking at the organic molecules, the amino acids that are found in meteorites, and the conditions under which they might fold and start to form the building blocks of life. She's based in Illinois. I could have gone out to Illinois and filmed her in the lab with a white coat, and I thought instead we should film her in an impact crater at the side of a Jain temple from the 10th century. So you can just see the outline of a very spectacular meteorite impact crater. And this elevates the visual aesthetic of the film. Of course, storytelling is central to any film, whether it's a narrative fiction or whether it's documentary. And in the films that I've made, they have not started with any kind of storyboarding. They've not involved any script. And rather, the narrative backbone has a framework from the outset that you then add the flesh to in the course of making the film, in the course then ultimately of editing it. And sometimes, as I mentioned, there is serendipity. This is Chief Mal Moses from a village of Endu in Vanuatu in the Southwest Pacific, with whom we filmed for Into the Inferno, the first film made with Werner on volcanoes. And we'd never met before. We show up, we put a microphone up his shirt, we have a camera in his face, another boom microphone leaning over him, and I'm asking a lot of questions. And this is where it becomes very important to not make it like an interview, but to make it like a conversation. It's a conversation. That's very important. And you leave space for someone to talk. You ask a question and leave space, because often what they say after they've stopped talking, 10, 20 seconds later, is what's really interesting. And I guess there are a number of other aspects to the films that become important. Humor is important. Obviously, you want to elicit emotion in the audience. In my films, I'm not interested in using special effects or graphics or reenactments. If I can't explain something in words through the conversations with the protagonist, then there are plenty of other documentaries that can use a lot of graphical material. The films don't set out to be didactic. I think they have an educational value, but that's not their primary purpose. Archive can be important, and again, this can be an important component of the research, is to identify archive that will help in the storytelling. And one of the things that I sought to do with all of my films is to put different kinds of knowledge on the same platform. Indigenous knowledge, scientific knowledge, the knowledge of faith leaders, the knowledge of artists. I think for me it's important to bring these into the melting pot. How many films have you seen, you came out of the film and you thought, that was awful, what an awful film? And the reality was that that film cost $100 million or $500 million. So a good film is not about the money. It's not about whether it has Brad Pitt in it. It's a magic ingredient that if filmmakers knew what the magic ingredient was, then every film would be brilliant. And I think a lot of the magic comes in the editing, because you have an infinite range of possibilities in how you assemble the material. And I've now done quite a lot of editing, and it's part of the process that I enjoy the most, because it's enormously challenging, and you might start with 1,000 problems, but one by one, you will solve those problems. Maybe I have something that's just not quite working, and then I realize I take it out. I take this clip out. If I take it out, the problem is gone. I don't even need to, it was never there in the first place. Or maybe I see something at minute 58 that if I move it to minute 14, there's a beautiful connection that I hadn't originally noticed. So I think the editing process is very exciting, very creative, and it's where perhaps you can hope for the magic dust to fall on your movie. We heard some music earlier, and music is very important in film. If you're familiar with any of Werner Herzog's films, you'll know that music is very important throughout his career in his films. It's very important to me as well, and in fact in all the films that I've made, we've had some local music has crept into the film, but also we've worked with musicians, composers to make original scores. This is a little clip from Fireball, where there is a dance performed by the people of Mare Island in the Torres Strait, and this is a dance that recreates meteors flying across the sky with the sparks flying off them, and for the Mare people, seeing a meteor, it presages a death in the community, and so they have a great significance. See the fire torches here that they light, and they beat these together, and the sparks fly up into the sky. Okay. And the film that we're going to see next was finished last year, a film called Volcano Voices. This was a bit of a different film for me. It was done on a very small budget as part of a series of workshops I was involved with in the Center for Interdisciplinary Studies in Bielefeld in Germany. And this was a film that wasn't driven so much by a vision as an opportunity to make a film. And this made it very difficult, actually, because I had to then retrofit a narrative to the footage that I'd collected, having conversations with participants in our workshops. So you'll see that film shortly, but I also wanted to just make a plug for the ZIF, Center for Interdisciplinary Studies. They have a number of programs, networking programs, cooperation group programs that you can apply for. It is a centre for interdisciplinary research, so that's a vital component of any bid, but I could easily imagine constellations of you here maybe finding this an attractive venue to have future congregations. It has on-site accommodation, they prepare your breakfasts and your lunches, the facilities are world-class, and we held over a two and a half year period, we had 5 workshops, firstly with climate modelers, one with archaeologists, one with historians, one with proxy experts, another one with historians. They were extremely fruitful, and the film that you'll see is one of the fruits of that program. All right, that's all I've got to say for now. I don't know, do we go straight into the film? Is that the idea?
Come preferisci? Abbassiamo un po' le luci?
La slide. Maybe it's better with the slide.
The last slide.
Abbassiamo un pochino le luci. Sì, sì, perfetto.
So I'm going to start the film. So I made I made some Italian subtitles for it. When I say I made them, Google made them. So if the translation is terrible, let me know and I'll just take it off.
This tranquil lake was born of fire 13,000 years ago, a cataclysmic volcanic eruption that tore through the earth, its fury shaping the landscape we see today. Now, the crater left by this destruction has filled with the serene waters of Lachazé. But this spot is far from the Pacific Ring of Fire or other famous volcanic zones. It's in the wine-growing region of Germany. Here, amidst the stillness of the lake, a Benedictine monastery, Maria Lach, now stands. Its cloistered walls, built from the multicolored volcanic stone, a testament to both geologic legacy and centuries of faith. Within the rocks beneath the surface lies the memory of an eruption so vast that it forced the people of the time, the Federmesser, to flee, their stone tools and culture abruptly scattered in the wake of nature's wrath. The dust spread high in the atmosphere by such violent eruptions creates a veil that dims the sun, casting a cold shadow over much of the earth. Crops wither in the chill, pastures turn barren. Famine may follow, and disease, migration, conflict.
I've been studying eruptions that shook the world for most of my career as a volcanologist, and it still amazes me how an eruption of a volcano on one side of the Earth can impact societies on the other. But I don't do the research alone. I collaborate. I collaborate with climate scientists and archaeologists, historians, tree ring and ice core specialists. And it's the joy of collaboration that makes the research so much fun. This film will explore the forensics of studying eruptions of the past. But more than that, it will unleash the unbound curiosity of my colleagues and reveal the importance of listening to experts in different disciplines, even listening to artists who also seek to represent and understand the world around us. The ideal venue for such conversations is the Center for Interdisciplinary Research, just a few hours from this spot. It's the best place to have conversations that cross disciplines, without borders. Let's go there now.
What makes the Centre special is that it supports groups of researchers, not just individual scholars. Founded in the 1960s, it moved to a purpose-built campus on the edge of Bielefeld, a town many Germans claim doesn't exist. Despite its brutalist architecture, the campus has a warm, welcoming feel. The apartments are comfortable. There's a convivial canteen and a swimming pool. There's even a small helipad. Back in the 70s, it was imagined that future scholars would arrive by personal gyrocopters. Of more practical benefit were the self-service coffee machines, which energized our discussions on how volcanic eruptions shaped climate and history. We even found another stimulus here: art. When our research group gathered, we were welcomed by the vibrant works of Anna Gudjonsdottir, an artist in residence whose creations adorned the Institute's walls. Anna had been virtually born in a volcano, a fiery origin that seemed to echo through her work. It felt only natural then to invite her into our fold.
I come from Iceland, so actually I grew up in a crack. A crack, when I say that's the earth opened up, earthquakes, volcanic eruptions. So and the fissures are in Iceland, very visible on the middle Atlantic ridge. And for me, I was just a child, I was playing that, I didn't know anything about that. And actually through this, I think just through my childhood, I learned, it was actually like a teacher. I learned sort of a language of form, a language of lines, a language of space.
Anna figured out our academic collective quickly. I asked what she had observed in our meetings.
Freedom, openness, new possibilities. I see this passion as well, and then the people asking questions, so curiosity, the passion, the curiosity, and that this is somehow what I felt is the same in arts, or I knew with musicians, and then of course it's fantastic when you meet other people and you can make this even grow. I noticed how important the image becomes, and what impact it has. And this is something that I actually, when I looked at my works here, I thought, it's there as well, but I approach it in a much more abstract way. I am actually going away from reality a bit. I mean, reality and the movements in life, I would say, the movements in life, the movements in nature, and the movements of Earth, it's all there. I see that also, no matter how dry and scientific the people are, it's just, you see how creative they're going. I notice this all the time with the people when they talk about their, what they found out about their truth and telling their stories.
To hear the story of volcanoes and climate, I listened to Anja Schmidt. As a teen, she wanted to be a professional footballer, but a visit to Iceland steered her to volcanology. Her knitwear suggested a recent trip back there. This was so, and she began by sharing her adventures.
It was a beautiful day, like cold, sunshine, and just perfect. We were standing on a hill and we were looking right down into the volcanic vent. You saw lava fountaining out and it smells of sulfur. And then put your gas mask on, and it's amazing. And I just feel very alive when doing these things. And we are flying a drone, and it could hover in the plume for 20 minutes and sample.
While Iceland's largest eruptions feature prominently in research on climate history, the eruption that really showed how volcanoes affect global climate was that of Pinatubo in the Philippines in 1991. It's not the ash clouds that cool the planet, but the sulfur emissions.
So volcanic eruptions emit gases like sulfur dioxide, for example. And once these gases are in the atmosphere, they react with other species in the atmosphere. And sulfur dioxide specifically, it can form what we call sulfate aerosol particles. And these are really, really tiny particles. The diameter of a human hair is around 50 to 70 micrometers, and a sulfate aerosol is 0.5 micrometers. So really, really tiny. You can't see it. If you just think about one aerosol, you can't see it with the naked eye. But actually, if you have a lot of aerosols, then you can actually see it in form of a fog, for example, or air pollution.
Collectively, the sulfurous dust forms a layer in the stratosphere, seen between blue and red sky in this photograph taken from the space shuttle a few months after the Pinatubo eruption. And here, a NASA satellite's view of the dust veil spreading above the entire globe, from the equator to the poles. The high-altitude haze acts like a sunshade, cooling the surface of the Earth and shortening growing seasons, the effects being strongest in Europe, Asia, and North America. From the ground, the sun may seem dimmed or haloed by rings, its light strange and intense. These twilight paintings were made by the River Thames in London following the great 1883 eruption of Krakatoa. Anja researches the climatic effects of such hazes using sophisticated computer models.
So a model is an attempt to represent reality or processes in reality. So it's mathematical, okay, you describe processes mathematically, and then you try to, what we call model simulation. So we change certain parameters. For example, in a climate model, you can simulate a volcanic eruption in year 2025. And you do this by, for example, setting up the parameters of this eruption. Where does the eruption take place? How much gas is emitted in the atmosphere? And then you let the model, on the basis of physical equations, for example, calculate the climatic impact of this eruption. I use models of different complexity. What I mean by that, it can be relatively simple models, so that could be maybe 5 lines of code, and it can run on anyone's laptop, okay? And then on the other end of the spectrum, I use very complex, very detailed models that have millions of lines of computer code. And during my career, I might have modified maybe 100 lines of that code. Yeah, so it's a collective effort to build these climate models. And these models run on supercomputers, so you cannot run them on your own laptop.
In this way, Anya can study the impact of any eruption, real or imaginary, so long as the amount of sulfur can be estimated. But there is another ingredient to her research.
I think you have to be willing to learn all the time, and you have to be willing to ask questions. You have to read a lot around the topic, and you need to find the right people, right? You need to find people who are also willing to go on a journey with you.
If we want to run models like Anya's, how do we know which volcanoes erupted in the past and when, and how much sulfur they emitted? On the volcano itself, we can find the rocks and study their composition, date them, and figure out the size and nature of the eruption that produced them.
This is a spectacular geological section for a volcanologist, especially the sequence of layers of pumice and ash and larger blocks. This is the story of the eruption written right here. This is the archive of the volcano. All of this is from the eruption 13,000 years ago of Oaxaca, and we can read from the shapes and sizes of the fragments of pumice in the deposit, from the thicknesses of the layers. We can read the story of that eruption, how long it went on for, perhaps a matter of weeks or a few months, how high into the atmosphere the ash cloud soared, and how far the hurricanes of ash that plastered the terrain, burying valleys up to 60 meters depth. We can read all of that story right here from the rocks.
Leaf and fruit fossils in the ash show that the main eruption occurred in late spring or early summer. Lesser eruptions in the following weeks dammed the nearby River Rhine, creating a temporary lake. All this and more has been revealed by studying the deposits at Oaxaca, but it's not practical to do the same for every volcano in the world. To learn about global volcanic activity and its climate impact, we need to look far from the volcanoes. In fact, we must travel all the way to Antarctica and Greenland, where dust from major eruptions eventually settles in the polar snows. One of the leading specialists on the glacial archives drilled from the ice sheets of Antarctica and Greenland is Michael Siegel. Growing up in Bavaria, he didn't seem destined for polar studies, but it seemed a good direction after a project studying trees in Saudi Arabia, a country not celebrated for its forests. First, Michael explained how we get records of global volcanism in the ice.
Every year, snow is falling, and when the snow falls, it takes a sample of the atmosphere, and that falls on the ice sheet. And then next year you have snowfall again, and that is then closing this layer. And it's like a book. You're building up page after page for many thousands of years, and you can date them very precisely by counting then the annual layers.
If there is sulfate aerosol from a large eruption reaching the polar regions, that too will fall to the surface to be preserved in the ice.
Then with a time lag of about 6 months or so, it falls down on the ice sheets together with the snowfall, and then it forms here this sulfate layer on the surface, and then with subsequent snowfalls, the next year you still have sulfate in the atmosphere, and then after 3 years it's washed out, and then you have this very distinctive marker, so sulfuric acid in the ice sheet.
Michael and his team work in places where snowfall is heavy, sometimes knee-deep in a single year. The layers of snow preserve clear annual patterns. Drilling deep into the ice reveals a timeline stretching back thousands of years. Each layer is a snapshot of the atmosphere at the time it fell, capturing gases, dust, and sulfur from volcanic eruptions. By tracing the cycles of winter and summer snow, Michael can date the ice. What emerges is an amazing chronicle of Earth's volcanic fury, reaching back more than 100,000 years.
Independent of if you go to Antarctica or Greenland, you go to places that are flat and white. Otherwise, you wouldn't go there. You're not drilling at a hill or where you have cliffs nearby that is depositing stuff on your ice sheet side. So you go really at the summits, and you don't see visually, you cannot even see any structure, so you have no idea where it's up and down. 2013, I led an expedition to Tunu. Tunu is in the northeastern part of Greenland, where you have the lowest snowfall rates in Greenland, so only 10 centimeters per year. And that allows you to get a 2,000-year-long record with a relatively small drill. Most of the bulk of the work in our field takes place in the cold room and in the lab. We get the core as quick as possible, and then we spend a lot of time decoding the signals that are stored inside.
The sulfur in ice provides the key input for modeling an eruption's climate impact: how much sulfur reached the stratosphere. This can be estimated based on comparison of the fallout in polar ice from atomic weapons tests, whose yields are known. While sulfur layers reveal eruption timing and sulfur amounts, identifying where they ultimately came from requires finding tiny ash grains, known as tephra, whose chemical signature can pinpoint the volcano of origin.
It's super exciting to do interdisciplinary stuff because you always learn something new. So you're an expert in your small little field, and it's a small little bubble, but you know almost nothing outside there. And you just need to start early with that, explore it. So when we were doing this research, for example, on the ice cores in Greenland, I didn't have any contact with the tephra people. I think I looked up Jill Blunkett. I have no idea how I got in contact with her, maybe just on a paper and then wrote an email.
Jill Plunkett specializes in analyzing the chemical fingerprints of tephra and finding the source of far-flung ash deposits. But Jill was not the most attentive pupil at school. It took friends to kickstart her academic career.
I had no intention of going to university. And one evening I read in the local newspaper that there was a lecture by an archaeologist who was coming to talk about the medieval record from my hometown. And I thought, well, I'll go along and see what that's about. So he talked about how they had dug down into levels going back to 1200 and all the things they found. And I found it absolutely fascinating. It's like, wow, I didn't know you could discover things like that. And then my friends at school said, look, you have to apply for university. And I said, no, I'm not even going to do my exams. There's no point. And I said, look, if you don't apply, we're going to apply on your behalf. So you might as well tell us what you'd like to study. So I said, I don't know, put down archaeology. And I ended up doing archaeology as a result of that.
Jill became even more enthused by the subject during a Viking excavation in Dublin.
And the archaeology was just fantastic. So the organic remains were preserved because it was a medieval site. So you're not digging the post holes of where the houses used to be. You were digging the houses themselves. The wood was pristine. And an environmental archaeologist visited the site one day, and he picked up the wood and he examined it, and he said, oh, that's a piece of hazel and it's only so many years, and we can tell what they were doing with the woodland. I was like, wow, I didn't know you could do that. You know, how can I learn to do that? And that's what made me decide to go on and do a master's where I could specialise in the more environmental aspects that helped us understand humans and their environment.
Jill also works with drill cores, but taken from another unlikely environment, the peat bogs of the island of Ireland.
I love bogs, right? So I think they're beautiful environments. They're barren landscapes, brown, dusty. We used to have to jump out of the way when the Bord na Móna machines came down and hide from the dust that was blown up. And still, I fell in love with them. Bogs only have their moisture coming in from the atmosphere, so they're perched above the water table, and they're only getting their nutrients from the atmosphere, so whatever comes in, whatever is blown in from the surrounding area.
That includes volcanic ash grains carried on the wind for hundreds or even thousands of kilometers from distant eruptions. The fallout settles into the accumulating peat. By taking cores from the bog and dating them with radiocarbon, Jill unlocks another record of Earth's volcanic history. But it requires meticulous work, often hunched over a microscope, to unravel secrets invisible to the naked eye.
You know, when you look at seeds under a microscope, it's incredible, the complexity, and pollen grains for that matter, tephra shards, they are beautiful in their own way. But it's more the types of information you can potentially extract from them, and not always just the information that you set out to extract. So you might want to find out what foods were people eating on a site, but then you might find out all sorts of things about the environment that they were living in, the weeds that were growing. It might tell you about abandonment. So you can potentially see things there that you didn't set out to find. The bits of dust that reaches far distant places is essentially a type of glass. So it's molten magma that has been thrown up into the atmosphere, fragmented, solidified. It's predominantly composed of silica and some other elements. And it's extremely light, so it can blow thousands of kilometres, tens of thousands of kilometres potentially. And the chemistry of that glass is strongly linked to the chemistry of the magma chamber that produced it. So by analysing the chemistry of the glass, we can hopefully link it back to the source volcano, and potentially even the particular eruption, because different eruptions can produce glasses of different chemistries.
One of the most puzzling samples Jill encountered led to Mount Paektu, on the border of China and North Korea, 9,000 kilometers away. She hadn't imagined the ash cloud could travel so far, but the sample didn't match any of the more obvious sources in Iceland. Eventually, she traced it to this volcano and its colossal eruption in the year 946.
Iceland, the tephras, the volcanic products are really well characterized. So we've got the data to compare with. But if you go to places like Alaska and the Aleutian Isles, the Kurils, Kamchatka, Japan, they've got so many volcanoes, and only maybe the largest eruptions have been characterized.
One of the largest eruptions in prehistory is the Thera eruption that shaped Santorini in Greece. While the rocks have been studied in great detail, a precise date for this Bronze Age event, which buried the settlement of Akrotiri, remains elusive. Finding when it happened would settle a decades-long archaeological debate. Archaeologist and tree ring expert Charlotte Pearson thinks we are close to solving this enduring mystery. But first, she told me how her own scientific odyssey began.
So I'm in the library and I'm looking at papers, and I find these two papers with tree rings. And one of them's from the Bristlecone Pines in California, and one of them's from the Irish Oaks in Belfast. And both of these papers are saying 1627, 1628 BC. something happens, this sudden short-term perturbation of climate. And we, in both those papers, we think it's the theory eruption. And it just that single kind, it was really like a kind of a magic moment, because I couldn't believe these trees on opposite sides of the world could include information in them dated to within 1 year that they could then suggest applied to this really important volcanic eruption.
Charlotte works at the birthplace of tree ring science, established in the 1920s by astronomer Andrew Ellicott Douglas. Fascinated by the relationship between the sun and climate, Douglas noticed distinct patterns of narrow and wide rings in tree stumps at a lumberyard. He realized these rings recorded regional climate patterns. Thicker rings indicated better growing seasons. Eager to track fluctuations in the sun's intensity, he began studying pine trees in the mountains, searching for climate signals with the aid of a photomechanical device known as a cycloscope. Later, Douglas hired Edmund Schulman, seen here coring a tree on Mount Lemmon near Tucson. Together, they laid the foundation for modern dendrochronology, a field now providing precise climate records spanning thousands of years. Schulman went on to date the oldest trees in the world, the bristlecone pines of the White Mountains of California.
I was up in the White Mountains on a collecting trip with the bristlecone pine forest, and there you're surrounded by these ancient trees. And the longest living of those that we know of so far is 5,000 years. So these are trees, they're standing in the White Mountains, and they're just growing a tiny little bit every year. The pyramids come and go, the tree is still growing. You know, I mean, it's mind-blowing, and it's kind of humbling to be around trees like that, and to pick a piece up off the ground and to look at the rings. And you just see data. When you get the privilege to look at something like that and you feel like you're contributing to the scientific picture, that's one of the biggest privileges you could have. It's a wonderful thing.
Tree rings capture climate shifts, including short-term cooling from volcanic dust in the stratosphere. For the bristlecone pines, one of the most striking anomalies is the frost ring of 1627 BCE that so captured Charlotte's attention. This points to a major volcanic eruption, and some suggested the Thera event. But the timing now looks too early.
I think the answer ultimately will come from the ice core record. If, as the new ice core records come out, we are able to see, or somebody is able to retrieve some volcanic ash from one of those acidity layers, the ash horizon would tie together the histories of all the civilizations in this region, in ancient Egypt, in the Levant, in Turkey, in Greece. It would bring them all together at one point in time. And so it has to be right.
Charlotte is optimistic that the answer will emerge within the next decade, thanks to rare solar storms. These storms bombard Earth with energetic X-rays, creating bursts of radiocarbon and an isotope of beryllium in the atmosphere. Radiocarbon is quickly captured by trees and living organisms, while beryllium leaves its mark in ice cores. Together, these pulses synchronize tree rings with ice core records. Since tree rings are precisely dated to the year, they provide exact tie points in the ice, opening new doors to the past.
It suddenly opens up a whole world of possibilities. We got 12,000 years or so for some records. And there's a potential to get at the data in every single one of those tree rings and make it count. Use it to understand chronology and the interactions between people and their environment.
Before we finished, Charlotte shared a detail of her academic journey that I found very profound.
I'm dyslexic, so I have struggled with, and I'm a chronologist, so with a sequential numerical learning disability. I've kept it a secret my whole academic life, and I haven't talked about it. And now I know that I can turn that around and use understanding things in a way that people don't, to my advantage, to see things from a different perspective. And so I think it's my greatest strength. And I've gone on that journey through my life, starting out with it being my greatest weakness and probably the reason I would never amount to anything. And now I feel it's probably the best thing about me because it's taught me the most about myself and about the world. So, yeah.
volcanic eruptions can alter the climate, with ice cores preserving records of global volcanism and trees tracking temperatures long before thermometers were invented. But how did cooling after major eruptions affect people? From the medieval period, monastic annals provide clues. Written by monks who observed the world from their secluded communities, these chronicles unwittingly detail the impacts of distant volcanic events. How the sun and moon were dimmed by volcanic dust, how crops failed, and how people responded to the upheaval. Later centuries provide more detailed economic data, such as grain prices. Cold summers shorten growing seasons and cause frost, while late rains cause crops to rot, resulting in food shortages. Rising bread prices highlight the links between unfavorable weather, poor harvests, and scarcity, which often intensified social and political pressures. Heli Huhtama is among the leading historians exploring such connections. Her love for the past dates back to her childhood in Finland.
I can trace quite a long way back my love for history. This is about the time when I just learned to read, and there is this Finnish children's book, actually series of books by Mauri Kunnas, who is portraying a Finnish history, and these were my absolute favorite books when I was a child.
Heli's love of books has endured. She's been studying the impacts in Scandinavia following several 17th century eruptions, including that of Huayna in Peru in 1600, seen depositing ash on the city of Arequipa in this contemporary drawing.
Every time when it's possible, I really do like to be physically in the archives, but these days it's a lot of online. And for example, my sources, what I'm looking at the moment, 17th century Finland, almost all of these are available online. So that's why I appreciate every time when I have the opportunity to go to the Dusty Archives, because it's our field work. The biggest thrill for my research is if I have a hunch that there might be some detail, some piece of information in the written sources, but I do not know where, then I start reading, searching multiple documents. It might take me 1 day, 2 weeks, 3 months, but when I do find this information that I had just a slight hunch that it might be there, this is the greatest moment, because finding it, and if I happen to be in these dusty archives, I have to control myself not to start jumping and screaming and woohoo, I got it, because you have to be very quiet in the archives. For example, the whole work with the climatic and social impacts of volcanic eruption. This is an accident. I was looking something totally else. Well, I was interested in harvest, but then I started to find this pattern. Oh, what was happening in 1601? Oh, 1641, 1695. Then these volcanic eruptions became visible other side of the globe in these sources.
The sources Heli examines reveal the far-reaching impacts of distant volcanic eruptions and the intricate details of how societies responded to food crises.
What influences the social impacts is a variety of factors. We do have natural or geographical factors, for example, location of the fields, elevation, soil types. You can see when there was different level of entitlement, for example, for food aid, if there was a poor relief, if the authorities tried to get grain from less affected regions. So these determined whether the bad harvest escalates to human crisis. Nature, environment, and climate is always there when there is a human society. It cannot be taken away from people.
Heli, who moved to Switzerland to work with Michael Siegel and other scientists, shared her insights on what makes collaboration successful.
the key is listening. The skill to listen, the patience to listen, colleagues from different disciplines whose language, the disciplinary language, you might first do not understand fully, but being able to learn this new language and listen and then start to build on their collaboration.
As a volcanologist drawn to Earth's most dramatic eruptions, I'd long dreamed of visiting Tambora in Indonesia, whose 1815 explosion reshaped history. While making this film, I had the luck to join a small team to study the pumice deposits. Our driver navigated the roads, mildly distracted by the car's entertainment system, but we arrived safely. Our host was Indranova Suhendro, a Javanese volcanologist whose fascination for volcanoes began in childhood when he became captivated by the story of Tambora. Our rental cars could only take us so far, but we found a way to get closer. Despite the enormity of Tambora's eruption, finding rock exposures proved challenging. With help, we located an outcrop, and Indranova deciphered the eruption's story from the layers of pumice and ash.
So here, this is the ground before the eruption, and then here you can see this grayish ash. It's on the 5 April 1815, and then we have this thick and loosey pumice fault deposits. And then from 5 until 10 April, the eruption intensity decreased, producing this dark layer here. And then suddenly the eruption intensity increased. And this time the Plinian eruption is much more powerful for about 2 to 3 hours. And it makes the conduit unstable. So the plum began to collapse. And it produced the monster, the monster that we call pumice-rich pyroclastic density current.
An eyewitness to the 1815 eruption described the monster like this. The mountain appeared like liquid fire, and a violent whirlwind blew down nearly every house in the village, carrying them into the air together with men, horses, and cattle. The searing clouds of ash and pumice took thousands of lives, while the devastation of crops under thick ashfall led to famine and disease, claiming tens of thousands more. In the following year without a summer of 1816, crops around the northern hemisphere would wither too, as Tambora's sulfurous dust encircled the globe. To grasp the effects of what's been called the West's last great subsistence crisis, I turned to Bruce Campbell, a historian skilled at tracing hidden rhythms in records of grain prices.
In Britain and Ireland, the biggest challenges to agricultural production were sequential years of very wet weather, particularly very wet weather when it comes to ripening period and harvesting period. And if you get 2 consecutive years of bad weather and bad harvest, it's very, very difficult for society to survive that without considerable tightening of the belt or worse. Famines typically occurred after a double harvest failure, what we call a back-to-back harvest failure. So what you have in 1816, 1817 is what looks like a back-to-back harvest failure, and therefore a major food crisis. And when food is scarce, people resort to any means possible to sustain themselves and their families. So one of the clearest indications of stress is crime.
The dire circumstances sparked widespread reactions, including demonstrations in grain markets and bakeries. In May 1816, protests erupted in my hometown of Cambridge. In nearby Littleport and Ely, mobs also rampaged. Dozens were arrested and 5 hanged for burglary and theft. This is their memorial. In Ireland, where reliance on the potato was even more profound, the situation grew increasingly dire.
1816 really inaugurates what we call in Ireland the pre-famine period of increasing problems of growing population, reduced farm sizes, growing dependence upon a single staple crop, the potato, and that is one of the reasons why the Great Irish Famine was so devastating. Most people who die in famines do not die of starvation. They die of starvation-related diseases, of which typhus by the 19th century was the single greatest killer, along with smallpox and other crowd diseases, because when food is scarce, you get problems of crowding. When food relief is provided, people throng together in increasingly unsanitary conditions, which are ideal for the spread of typhus. The other thing that begins from 1816 is migration, emigration increases. So people with some land could sell it and get a passage across the Atlantic to the Americas. And people going on these ships when they're sick, when they've got lice. So people may think they're relatively healthy when they got on board ship, but they're not when they get off.
As ships bearing ailing immigrants reached Canada, fears of epidemics grew. This letter from Dr. William Hackett, written in 1818, recounts treating Irish settlers stricken with typhoid fever, quarantined on an island in the St. Lawrence River. This ordeal spurred the founding of the Hospital for Sick Emigrants in 1820. Bruce, freshly retired from academia, left me with a poignant reflection on a different kind of crop.
The young are the seed corn. I wanted to become a teacher. What this is what's gone out of my life in retirement is not talking to students. I like talking to people about things I like. That probably shows. My poor students had to endure that. But I really enjoyed opening their eyes, and then I learned from them. It took me a while to realize that you're an idiot if you do not learn from your students.
To explore the connection between historical disease outbreaks and climate change in an earlier period of history, I spoke with Tim Newfield. He began by sharing his lifelong fixation on disease.
My mother being a nurse, me growing up surrounded by nursing textbooks and leafing through them, a fascination with the history of health, and in sort of a One Health sort of concept. When I started out in academia, I pursued the history of livestock health until I was told that I was a weirdo, and if I didn't stop pursuing livestock health, I would never get a job. So I did, and I got a job. But I think an attitude that very much welcomes collaboration, where I just constantly want to learn from my colleagues and to discover new fields and new individuals that are able to help me make sense of the past.
Tim is especially interested in the first plague pandemic, caused by the bacterium Yersinia pestis. It ripped through the Byzantine world in the mid-6th century. Among Tim's favorite testimonies of the disaster are the writings of the 6th century scholar and statesman Procopius.
It's good reading. It's hard to put Procopius down. If you read Procopius's account of plague, I guarantee you will not take a break. You'll read it through, and you might pick it up and just read it through right again. Some of the accounts are really gruesome. There's accounts of 10,000 people or more dying a day, of the dead being thrown on rafts and taken to the suburbs, of the dead being thrown into the sea, people vomiting blood, pretty much almost anything you can think of. It's happening in Constantinople in 542.
What's so intriguing about this outbreak is that it came shortly after two massive volcanic eruptions that are recorded in ice cores. Tree rings suggest the worldwide dust veils from these events triggered the strongest summer cooling across the northern hemisphere of the past 2,000 years. Tim explained the possible link to the plague.
What has been said many times is that dramatic climate cooling upsets rodent populations either in East Africa or somewhere in Central Asia, facilitating the spillover of Yersinia pestis into people, which then spreads along trade routes. Crucially, we don't know where the plague responsible for the Justinianic plague was in 536 or in 540. Scholars debate that continuously, the location of Yersinia pestis. And beyond location, we don't know in what Yersinia pestis was the bacterium that causes plague. The species that would have been reservoired in, it's crucial to know what that species was in order to understand how the climate changes driven by those two large volcanic events may have impacted that rodent population, seeing to the spillover of plague into people.
As my conversation with Tim drew to an end, he reflected on the rigors of interdisciplinarity.
I think one has to be comfortable with failure, actually, because most collaborations ultimately do fail. One needs to be just so eager to learn more about their topic of interest that they keep going for it and going for it and going for it. And then just an unending desire to learn more from your colleagues.
While historians rely on texts, delving deeper into the past requires a different approach. Felix Riede turns to the archaeological record to understand how ancient societies adapted to environmental change. I asked what drew him to the deep past. His impressively hirsute muzzle suggested a childhood fascination for Vikings, but
I don't really know. That's a good question. You get it a lot, and I don't really have a particularly good answer.
regardless, Felix brings us back to where this film began, at Lachase. He has spent much of his career researching the human impacts of the eruption 13,000 years ago. This far back in time, the most tangible kinds of evidence that remain are the most durable.
Lithics stone tools are really great because we find them all over. People have been using stone resources to make their tools since 3.5 million years ago. So they really make up the backbone of our knowledge of deep history in a way. Here I have an example of a projectile point from around 13,000 years ago. We can tell a lot about the societies within which these objects were made. Each of the small flakes that have been detached here represent one moment, one action of a flint knapper, of a craftsman or woman. A projectile point of this size almost certainly wasn't an arrowhead, but much more likely a spear point. You suddenly compare two whole different economic systems and two different ways of interacting with the environment, interacting with animal species, but also two different ways of being able to extract resources from the environment. For instance, spear points, even if you throw them with the help of a spear thrower, are much less powerful than the bow and arrow technology. The other thing that I think is really important is that when you take a historical or archaeological view to societal change, you see that any change unfolds over generations. And the transmission of knowledge and know-how and of values is supremely important in that. And that perspective, I think, is really important for thinking forward into the future as well.
La Chazé remains a place of learning, passed down through generations, here at the Maria Lach Monastery. As we wrapped up our filming of the crater, we were invited into the abbey. We met Brother Stefan, an artist who works with paint, clay, wood, and stone, drawing particular inspiration from the rocks and trees around him.
I live with the stones. The old brothers from us know from what place the stone is. The black, they are gray, and they can say that's from this place or this place, so high, so deep. I think it's living.
He welcomed us to his workshop, built around the oldest part of the abbey, dating back to the 11th century. We sensed that in his art, he taps the energy of this hallowed ground, beneath which earthquakes reveal still resident magma, much as Anna Gudjonsdottir channels the volcanic and tectonic forces of Iceland in her paintings.
Here in the Eifel, it's important that I work with basalt and tuff. I don't work with other things. I think the stone is so fantastic, and I like it. I live on this place, and I think when I want to work with the material, I want to talk with the material, or I want to say something with the material, I must know it.
I couldn't help but notice a striking piece of timber, climate history etched in its rings. Yet for Brother Stefan, it held a different, more personal significance.
This is a tree from our graveyard, and by wind it's broken, and I want to do something special out of it, and that is an altar for a little church in Mönchengladbach. When the monks come back to the abbey in 1893, here, a tree 300 years old. I think it's really old, but when I work with a stone, it's a million years. That is a place for the glass works and the paper works, and medicine work for a little church in Burghausen near Munich.
I can see La Chazé as well on the walls.
Every time you see the lake in another way, I think the place is powerful. When you have a feeling for it, you feel it really fast. And I use this energy for my work. And when you go around the lake, you see it in the ground, the Mofetten. You can understand it, but you can feel it too.
Can we join you at Vespers this evening?
Yes.
And you'll be singing?
Yes, of course. This is today.
Misericordia, Deus, e poderies
really had the sense of nature and the geology and of course the climate and the history of that place and where I come from, my origin.
Avete domande, richieste, curiosità, informazioni, qualcosa? Altrimenti noi vi ringraziamo per essere rimasti qui fino a tardi e ci riaggiorniamo domani mattina per continuare il nostro convegno. Ciao!